So Ainsley, it's a ramp, right?
Yeah.
And there's a weight, a mass on the ramp.
Yeah.
And what is the angle here?
56.
Okay, so we have 56 degrees, and we have a mass up here, yes?
Yeah. 45 kilograms.
45. Okay, 45 kg. And it's just going to slide down, is it? Is there friction?
Frictionless.
Frictionless, okay, so no friction. And we're just looking for acceleration, are we?
Yes.
Okay, so the trick here is to understand that there are two forces involved. Okay. What are the two forces?
There's gravity and normal force.
Very good, very good. So we have Fg pulling straight down. And the normal force, what normal actually means is perpendicular. So that doesn't always mean straight up. So if you're sitting on flat ground, it's pushing you straight up. But if the angle is changed, the force is actually perpendicular to that. So we have a force pushing this way. And the sum of those two forces is actually what pulls the block down the hill. Okay? And so let's move these two. So I'll say this is Fn. And we're going to have some sum there. And so the way you do this, and I'll teach you this more later, but the way you add vectors is you draw them tip to tail and you see where you're at. So if we draw these over here, if I say this is Fg, and I start from the tip and draw the Fn, I'm drawing them a little bit bigger but same direction. Something like that, I would say. This is Fn. Let me change this so that it's clear. This is Fg. And this is Fn. And the resultant vector is your... This is the resultant vector, and we might call that Fgx, because it's kind of, if you take your coordinate plane and you tilt it, this is the x. Whatever you want to do. And so this is interesting because if you look at that triangle, let's just see if we can do this here actually. I need some blank. You take a blank sheet of paper and you draw this on it. This is just rough, but this is going to be right angles, right? If you take that and you flip it over, it's the same as the ramp. So this is, I don't know if you can see the drawing through there, but it's like this. And so this angle here
It's 56.
is the 56. So when you flip that back over, like, oh, how did I do it now? Like this. This is
56.
the 56. Okay, so your angle here is the same as this angle here. 56 degrees. So, it's actually, the physics of this is really simple. You just have to find the force, and then the acceleration is no problem, right? We know that the net force is mass times acceleration. So, once we get that net force, we can just divide by the mass and that'll give us the acceleration. The trick is doing the trigonometry to set it up to find this force, right? So So if we say, well, this is a right triangle, we know the force of gravity. We don't know the normal force, but we don't need to, because we have the angle and we have this side, so we should be able to have that side. And so if you're thinking, can I ask you guys to just whisper? Sorry, I'm making a video for one of the things. Good morning, Asia.
Good morning.
Trig. You guys know Trig?
Yes.
I see, yes, no, okay. Let's just do this quickly. Everyone say, Soka Toa. I just like saying it like that, I don't know why. Sine is opposite over hypotenuse, right? So, sine of the angle is the ratio of opposite side over hypotenuse. And then cosine of the angle is adjacent over hypotenuse. And the tangent of the angle is opposite over adjacent. This is all based on a triangle like this, where this is theta. This is the hypotenuse, the long side. The other side beside the angle is the adjacent, and the side opposite the angle is the opposite side. So that's basic trig. Let's go back to our problem. So we have the hypotenuse in this case is gravity. So this is our H, and this side is our opposite, right? So we're going to use sine. So the sine of theta is opposite over hypotenuse. Sam, yeah.
The side of the FN, isn't that the hypotenuse?
No,
You tell me.
it is not.
How do you know this is not the long side?
Oh wait, maybe.
Reason it through.
Oh, because it's a right angle.
So if it's attached to the right angle, it cannot be the longest side, right? That's good reasoning. So if the sine of theta equals opposite over hypotenuse, what do we want to find? We want the opposite side, right? So we just multiply this over. So h sine theta equals my opposite side, so fg sine theta will give us our, in this case it's the net force. So Fg we can figure out really easily, right? What does Fg equal?
45 times 10.
Good. Mass times G. So it's going to be 45 kilos times 9.8. That's going to be 450 or 440 or 4. What is it? 421?
441.
441. That makes more sense. So 441 newtons is my force of gravity. So this is going to be 441 times the sine of 56. And that's going to equal, I don't know, what is it? 365? 365 days a year.
Yeah, 365.6. So, yeah.
I like the number 365, so we'll just leave it at that. Now, that's the net force, right? It's not the acceleration.
That's mass times.
So if you do this divided by 45, that will give you the acceleration, which will be
8.1.
8?
8.1.
Is it? 8.1. You are correct. I didn't trust you there for a second. Did
Yeah,
you see
you
that?
did.
meters per second squared. Kind of makes sense, right? If it's got to be less than 9.8 because it's not straight up and down. But 56 is pretty steep. Is this drawn to scale? No, 56 is like this, right? So if you slide something down with no friction, it's going to be pretty fast. And as you get less, it'll be less and less. Is that answer? Okay. I'm gonna. Yes, Sam.
How do you know you had to times it by sin?
Because you have the opposite and the hypotenuse. Like you wanted to find the opposite and you had the hypotenuse and you didn't have the adjacent.
Oh, okay.
So this is the trig identity. It's just a ratio of opposite side to hypotenuse. So because the angle is down here, the side we want to find is the opposite, and the side that we know is the hypotenuse.
Okay.
So the sine of that angle is the ratio of the opposite side to the hypotenuse. And so we just solve that. We just put the h over here. You'll do a whole bunch of these if you go on to Physics 12, and we'll do a little bit this year too. And you'll just get to where you go, oh, this is FG sine theta, and it'll just sort of work. It's the opposite side, it's FG sine theta, and you'll just carry on with that. You'll get fast. The math is actually simple, but it's complicated the first time you look at it. So it's really good. If you did these, it's really good, because it'll give you a familiarity as you go on. Yazzie?
We have to know how to do, like, find the angle where it is.
How to find the angle?
No, how to find the acceleration angle.
For this, for your quiz coming up, no. For your quiz coming up is Newton's laws. You are supposed to, in grade 11, you're supposed to have two-dimensional kinematics. But that's fairly new. And so I teach it to you, but I don't really test you on it. Especially now, because it's so much to pack into one small thing. But the more you've seen of it and the more practice you have, the better for next year. Good morning, everyone.